We just finished registering our blockchain node. For example, our 5000 node knows that 5001 and 5002 are next to it. Same with 5001. It knows that 5000 and 5002 are next to it. So let's say this person A has a wallet. The blockchain node gateway is this one. So person A will send the transaction here. This node will verify the transaction, and once it's verified, this transaction will need to be synced to the other nodes. And this is the section where we'll be working on from now. In real life, P2P network will be used in most cases, but for this, we'll be using REST and send the data. But the concepts are the same, so please keep this in mind. From now, we'll work on taking this transaction and syncing it to the other nodes. We'll be taking this blockchain node side and updating the transaction and also clearing and deleting the transaction. Those are the functions that will be needed. Update and delete are the actions we want to accomplish with this blockchain node's API, and that's what we'll be creating from now. For this, let's go to Projects, Blockchain Server, and access blockchainserver.go. This is the code we previously wrote, and we have our API named Transactions. We only have here method get and method post. So from now, we want to use a method called put to update and delete for deleting. What we have here for method post, we're going to copy this and paste it down below. We've copied and now we're going to paste here. Now this has been pasted and we'll rewrite our method name, method post, to method put. With method put, this means we're going to update. Post and put aren't much different, so let's review our code from the top. We receive our body here and include it in transactions, and we're decoding here. This section is for error handling, which is followed by create public key, signature, and blockchain, and calling on create transaction. Let's look into create transaction. Previously, we wrote a comment to do and sync, but instead of calling on create transaction, we want to directly call on this add transaction. We want to do this because if we call on create transaction, we see from our visual on the right that we'll sync the transaction with the other nodes. But if the sync side is also performing create transactions, it'll sync with other nodes. So we only want the node that was updated to add transaction, and within this, we'll refer to verify transaction signature and update its own transaction pool if the transaction's verified. Now let's go back to blockchainserver.go. Under our method put for blockchainserver.go, we'll rewrite this create blockchain transaction to add transaction. For this is created, we'll rewrite this to is updated. And for the one below, we'll rewrite this as well. And this won't be 201, but our default is 200. So we'll want to return 200 and return success. This is our method put, and now we want to create our method delete. So here we'll write case HTTP method delete. In this case, first we want to write BC and call on BCS get blockchain. We have our transaction pool and we want to make it empty. In order to access our transaction pool, public is for read only, so that won't clear the transaction. Let's access transaction pool, and we want to add on a method for clearing our transaction pool. For this, we'll write func bc blockchain. Then clear transaction pool. When this is called on, we want to clear our transaction pool. This will be bc transaction pool, BC transaction pool 0. This is how we'll clear the transaction pool. And right now we have 0 transaction pool slices stored in here. We've created our clear transaction pool, so let's go back to blockchainserver.go and under our method delete, let's update this to clear transaction pool. This will be followed by IO write string, W string utils, JSON status, success. Now let's go back to blockchain.go and previously we wrote clear transactions. That's the section where we wrote to do. So it's right here. Let me bring up my visual here. And for example, when this blockchain node's transaction pool comes in, the other nodes are synced. This is the section that we want to work on from now. We'll delete our to-do and we'll write if is transacted. So it's been verified and our transaction is added on its own node. Then we have BC neighbor. We'll send a transaction to the other nodes inside BC neighbor from now. So once again, we'll write public key str and send the necessary information for the transaction. We'll write fmt sprintf %064x %064x, followed by sender public key x bytes, then sender public key y bytes. This is how we create public key str. This will be followed by signature str, signature string, then comes our transaction request. This will be transaction request here, then sender, recipient, public key str, value, and signature str. We want to send the 5 pieces of data in JSON format, so this information received by create transaction is changed into str so that it can be sent. Next, we have JSON Marshal BT, then buff bytes new buffer. So we want what we JSON marshaled and make it a buffer and later on send as HTTP. Then comes endpoint, so where we'll be sending. We'll be sending as res, so we'll write %s and a node's address will be placed here. So when we pass the node, our endpoint is created. Then comes client, HTTP client. We've covered this before, and Golang didn't import this automatically, so we'll scroll up and include net HTTP and get back to our code. We wrote HTTP here, so that's why auto import wasn't working and this happens. When this happens, just scroll up to the top and manually input. Now all we have left to do is to throw in our requests. We'll write request and HTTP new request, put endpoint and buff. We'll pass these in and response. This time I'm going to not do error handling. We'll write client do request. Then our last line is log printf %v response. Now let's refer to our visual on the right. We were able to complete the section for updating. This time when this blockchain node got a new block, we emptied our transaction pool. We want to write the section for emptying our transaction pool. So we want to write a code similar to this for our delete. So let's copy what we currently have and search for a file called create block. Right now we have create block. Within this, we've cleared our transaction here. But after this, we need to send a request for a delete to the other nodes and clear the transaction pool. For this will be range BC neighbors and paste our code from before. This time, it won't be put here, but delete. This buff will be nil. When we create a new block, the transactions in the block will be emptied, and the transactions in the other nodes will also be emptied as well. And now that we've gotten this far, let's test this out. Let's get our 5000 to 5002, so all 3 of the blockchain servers up and running. That's what I'm doing right now on my side. And once that's completed, we have our wallet server 8080. Let's get that up and run that as well. We have all our blockchain servers and wallet server running. Here, I'm going to bring up my browser, and I have our 00005000 showing right now. We have nothing for our transactions here. Next is our transactions for 5001. My third tab shows the transactions for 5002. We're looking at the transactions data for the 3 blockchain servers. Next, I'll be showing person A's wallet, and this is person B's wallet. We'll copy person B's wallet's blockchain address and paste it on person A's wallet's send money address. We'll enter 1 and send. This wallet server's gateway is right now 5,000, so we do have a transaction in 5,000. But this time we wrote some codes for syncing with the other servers. So let's access our 5001 and refresh. We see that our transaction is also displaying here as well. The same goes for our 5002. Let's now change our amount to, let's say, 2, and click on Send, OK. Once more, let's access our 5000. We see the transaction 5000, which is obvious. Then how about 5001? Since it has been synced, the transaction is also showing here as well. Same goes for 5002. We want to take this transaction and perform mining to create a new block. We'll access 5000/mine and perform mining here. After we receive a message success, then let's access our 5000's transaction and click on refresh. We see that our transaction pool is empty. We'll refresh our 5001's transaction and it's also empty. We'll do the same for 5002 and it's also empty. This brings us to the end of our lecture regarding syncing transactions.